Sweets from a certain manufacturer sold in packets. 30% of them are orange, and these are randomly distributed amongst the packets. Each packet contains 15 sweets. The number of orange sweets in a randomly chosen packet is denoted by X. Find these probabilities. So this is a binomial distribution because we've got a fixed number of trials. We're looking at 15 sweets and 30% of them are orange. The chances of picking an orange with any given sweet is going to be 0.3. So if we want to work out the probability that x equals 4, we can just use the binomial distribution function on a calculator. I will talk about what it's actually doing, but we go to distribution, binomial PD, variable just to find 1, and I'm putting in 4, 15, and 0.3. Your calculator might look slightly different to mine, but hopefully you can find it and figure out. So 0.2186, so 0.219. So the way this calculator actually just worked that out is that imagine you had just 4 orange sweets in a row. It would be 0.3 to the 4, the first 4 that you find, and then it would be 0.7 to the 11. Okay, 4, basically you're getting 4 orange and then 11 not orange. But we can look at all the different ways we could arrange that because maybe I get not orange and then 4 oranges. So we have to bring in the choose function, 15 choose 4. Because what that is 15 factorial because that's the number of ways that you can arrange 15 distinct objects. But 4 of them are actually the same, so I need to account for that. Every single permutation, I could actually arrange the orange sweets in 4 factorial different ways, and I could do the same with the ends. That's a very quick little overview of the binomial distribution, but that's how it works, and that's what your calculator's doing. For greater or equal to 4, well, I know some graphical calculators can just figure this out straight away, but mine only can deal with less than or equal to probabilities in the cumulative distribution. So I need to do 1 minus the probability that x is less than or equal to 3. See, I want to include 4, so I'm not going to minus x less than or equal to 4. It's going to be the one below that. Okay, I can go back to distribution, binomial CD, variable, and it's actually stored everything in here. I just need to change it to a 3 now. And it is 2 marks, so I'll just write this down, 1 minus 0.2968. And then I can't remember if it stores it in the answer button. I always just do it. I store it there, then go 1 minus, let's see if it did work. 1 minus answer, yeah, it does. Otherwise, it would be 1 minus alpha, and then the little minus sign here. 0.703. Then asked to write down an expression for probability that x equals r. So it's making us use the formula essentially. So I'm going to do it without looking in the formula book, but I will also quote that. Well, if there's r successes, then it's going to be 0.3 to the r, and then there'll be the rest of them will be failures. So it'll be 0.7 to the 15 minus r. Okay, it's however many are left over. So if r was 2, it'd obviously be 13. And then again, I just need to think about the different ways to arrange using the same idea as this one, but this one I don't know how many O's there are. It's going to be 15 CR. 15 factorial over r factorial times 15 minus r factorial. Okay, if you're struggling with that, then I mean, spend some time on it, get your head around it. But for the purposes of quickly preparing for exams, it's here in the formula book. We've got that is the same thing as NCR or NCX here, and then they're using p to the x times 1 minus p to the n minus x. So hopefully you're happy what this all represents. This is like the number of arrangements, and then this is the probability of every single arrangement. That's what's going on. Lastly, there's a link to the binomial theorem or binomial expansion. Explain the connection between our answer to part B, part 1, okay, specifically this one here, and this binomial expansion. So if I did the binomial expansion, and it says for a specific value of n, so it's got to be n is 15, okay, because that was what we're using before. Then I could expand this as 0.7 to the 15. You can get out your formula for the binomial expansion if you want, and then it's going to be 15c1 times 0.7 to the 14 times 0.3, and so on. Now the thing is, this in the expansion is actually the probability that x equals 0 in our distribution, and this is the probability that x equals 1. So I wrote down, I wasn't specific enough, I just said the terms are the probabilities for x, which is true, but we're asked specifically for this one here. I didn't quite know what it was getting at when I did this question, I've got to be honest. But it wants us to say, right, well, the first term is actually the probability that x equals 0. The second term is the probability that x equals 1. And therefore, probability x equals r is the r plus first, or th, not quite sure what to use here, term in this expansion. You could have maybe have written it around the other way, so started with 0.3 to the 15, and then it would actually be the r minus 1th term. But if we kind of do it like this, then it's the r plus 1th. Okay, well done.